First, and then I think it was pretty good.
Yeah, it's a good spot. Let's see.
Just give it a second. It's got to settle down.
Yeah, sellable. They charge me $10 for it.
Oh, okay. You have to call him and say you want a refund.
Right.
There's a mark and fork down there.
So, yeah.
Alan, as soon as everybody's seated, we'll get started.
Cool.
Yep, no worries.
It's going to be a while. I will. Hey guys, I gotta run back. I got calls. So that. So I will slip and eventually grab food. I'm 10 minutes late for a call.
Okay.
You guys need anything from me?
No, we appreciate it again.
Cool. Awesome.
This spot,
You
this
guys
spot.
got my number. If you got to call me, I'm just right behind this door. Okay.
All right,
Thank
man.
you very much.
He's not going to do the spiel?
I doubt. Doesn't sound like it.
All right. And you do the spiel.
I will.
Yeah.
Which one of those has the microphone in it?
Hmm?
Which one of those has the microphone in it?
Both of them.
They both do?
It does now noise cancellation.
Sorry?
If you use both of them, it does noise cancellation
Oh,
between the two.
wow, that's cool. They're spendy though, aren't they? Are they like $180 or something like that?
Yeah, for the newer ones, yeah. This is the first generation. About 140.
Oh, and you're watching it on your phone too?
Yeah, just to make sure I have the sound this time.
Oh, mac and cheese.
I missed
Mhm.
I missed the last one.
I don't remember if I thought we had problems last go around, didn't
We
we?
did. We had sound issues, and I couldn't get the stream in time because last time I used OBS, I hadn't done that kind of scenario where the presenter was local for a while and it wasn't set up correctly.
You gonna do a redo or what?
I asked him. He wasn't wanting to. He's very important. Yoga's very critical person. That's the beauty of being here. You get to hear everything, whether it's something you want to hear or not. So,
But he was supposed to demonstrate his scripts and how they had kept.
and we got it. Just the first 20 minutes is no sound, unfortunately. So if you just lip read for like the first 20 minutes when you can't see his lips, you're good.
Is there anything on the site?
Well, he was supposed to send it to me and never did. I'll have to send him an email.
Yeah.
He told me he was going to send it, and then if the speaker gives me their material, what I'll usually do is go to the AZPosh blog and stick it in the same article. That way, if you want the stuff for the
Yeah, because you said that he was gonna have some shells and where he measures the time, the execution time, and
yeah, I'll reach out to him.
Oh, you're talking about his very first one. If you go to AZPosh YouTube channel, that's the first time we have Yoda on it. Keep on calling Yoda.
Yoder,
He's talking about the
Jason Yoder.
he's talking about the first time we had Yoda on, where he was talking about where inventory time.
Yeah, the one that we
every time the
did
script ran.
when we did it at Pulte
Yeah,
back in 2016.
yeah, that was a while ago now. But let me find
Is it
it.
that long ago?
Yeah, it's been a while ago.
I was like 2016 or 2017.
I started this group back up in October of 2015 was the first one I did.
Okay.
And we did it at Minder Binder of all places. It was really loud in there, but I didn't know where else to go because I'd only been here like 2 months.
Right.
When I moved from Austin.
It was a great introduction.
Yeah. So I think we're ready to get started. Welcome everybody to PowerShell for the month of May, AZ PowerShell. And tonight we're going to have, our topic is redacting images with PowerShell. And the speakers are Allan Martin, who's on the phone, who's in California, and myself. We both worked this together as a team to be able to get this to work. So take her away, my friend.
Great. Okay, thanks. So hopefully you can hear me okay. So we're going to be talking about, as Thom mentioned, how to redact, in this specific use cases, images or TIFF images and different data types, but our focus is with TIFF images. And the reason why we're talking about this now is that we've noticed, my name's Al, actually, let me introduce myself. My name's Allan Martin. I'm in a company called AB Martin that specializes in data privacy, data obfuscation, both on structured, meaning SQL Server, DB2, Oracle, Teradata, Sybase type of databases, down to obfuscation of unstructured and redaction of unstructured data, like the TIFF images that we're going to talk about today. And what we've noticed is that a lot of data these days that are stored in large corporations, a lot of it is growing exponentially, and a lot of unstructured is overtaking structured data. So a lot of critical information for companies are stored in databases, your regular flavors of databases, but more and more the complete business, what constitutes a complete business object for a customer or user or an employee record, spans across the unstructured. So when I say unstructured, of course, like TIFF images that may be resumes or things like that. So and this is a challenge in the industry, because typically when you connect to database and do redaction or obfuscation of data inside databases, you leverage the Oracle or the database client, for example, or you'll connect to JDBC driver or ODBC driver, and you've got this structured fields and data types and columns and all these neat columns and rows where you can pinpoint the data and obfuscate it. Whereas things like images, it's a lot more challenging. And to note that it's, when we talk about today, when we talk about TIFF images, we're not just talking about the standard what you made. There are multi-page TIFF images that are different bit depth resolutions. There's many, scanned checks, for example, and things. We're going to go into that a little bit. I'm going to save you from the slides and get into the actual PowerShell stuff. So I'll try to be as quick as I can here. I only have a few slides. So a couple of use cases that we found there. We had a very large bank that had several million multi-page TIFF images that contain monthly bank statements, which have people's names and information, personal PII information or personal credit information, which by law we're supposed to, and to keep in compliance, we have to make sure those are redacted. Now, when I say just a couple of things, when I say redact, you might hear me say obfuscation or masking or redaction. When I talk about redaction, that's kind of what Thom had mentioned earlier on. Redaction, I think of redaction as replacing data with X's and O's or black boxes or white box redaction, for example. When I talk about obfuscation or changing data is actually replacing like for like. So if we have a TIFF image that has a social security number in there, instead of just putting a black box or a white box, we can replace that social security number with a like social or a like credit MasterCard for another credit card. So we can replace data instead of with X's and O's, we can replace data with
555.
like for like stuff. So we also had another customer, a large restaurant chain that had receipts and credit card information that was stored as TIFF images. The system, the back-end office system, was scanning the receipts as TIFF images. By law, they're out of compliance, so they need to have a solution to redact those TIFF images and take out just the sensitive data. And it goes on and on. So we have a lot of examples. One of the big ones was a large hospital that had patient information scanned and stored as TIFF image. They would store that in a content management system, or in this case, SharePoint systems. And by law, they were out of compliance. Any questions? Is it making sense?
Yeah. So were you doing that mainly for, Allan, your use case, was it mainly for test data management, or was it for just...
Yeah, so some of these were for test data management. That's the GB Bank. The hospital, sometimes there's reasons why we have to do this, not because we want to, but compliance. There's a new California regulations that's forcing people to forcing companies and corporations to remove sensitive data. So normally and companies must, by law, depending upon the compliance, they need to keep the data around for up to 7 years. So, but they also still have to obfuscate or mask or redact the user's personal information. So there's a lot of reasons, and the biggest driver is compliance and the fear of getting audited. So, so these are real customers here that we've dealt with. And as I mentioned before on this next slide, is that
we got a question for you. Hold on, man.
Yeah, go for it.
So the redaction and obfuscation, is that done real time, or is that done through a process at a later time and date?
Yeah, good question. So there's two ways of we do this. We do dynamic data masking, DDM. So that's kind of masking data in flight. which is pretty cool and pretty interesting. I can show that to you. But the second piece is static masking as well. So the use case for static, like we had one customer, and what they do is they do testing. So every month they pull from production a couple of million records in a several million records in a bunch of tables. They move it over to QA, to dev, to test, to UAT, to training, to sandbox, all these different environments. And by law, they have these associated TIFF images, hundreds of thousands of TIFF images they need to use for testing. And so they can't have any sensitive data resident on these QA, dev, and test systems. So in that case, we master data before moving from production area down to the test development area. We'll master data statically. Back to your question, we've had customers where they said, depending upon your roles, user groups and roles, if Thom is looking at a hotel guest folio, Thom may not have permission. And so what happens is in flight, we will redact that image. In flight, we'll redact that image and change the sensitive data so that user can look at that info. So Thom can look at the information. If Thom's manager, Betsy, looks at the exact same document, you got
that right.
I just picked a random name.
Yeah, sure you did.
So, but if Betsy looks at the same document, it won't redact. It'll do minimal redaction. So that's kind of masking in flight or dynamic data masking. Sorry, I was just taking another sip of my beer, water. So this, so on this, the reason why this is so challenging is because when some data, we're talking about images, we're talking about pixels and pixel manipulation, RGB values for that pixel, all these different types of settings for just one pixel. So the idea is that we've had this. What the images that you're looking at, we've had this request already. So we've got driver's licenses. We've blacked out the image. We've actually replaced the driver's license with another fictitious driver's license, California, because they wanted to do testing that way. We've got a check where we've obfuscated the check and just changed values instead of just putting black boxes of redaction.
So you have to cross out their names, but you can leave the address alone?
You can specify by XY coordinates. We can change values, which Tom's going to show you. So we can change values based upon XY coordinates. So if we have a standard image or a template, we will go ahead and address that. Tom's going to, yeah, we're almost done with the slides here, but Tom's going to show you the capabilities. The method that we use is no third-party software. We can do it all using PowerShell and components of the Windows operating system, the .NET classes and things, and Tom's going to show that to you. So we don't need to buy, we don't need to get any other third-party software, which is cool. We can use it all within PowerShell to do all of this. I mentioned we can draw shapes, and we can draw text and transparent objects. We can do color, we can do highlights, we can do a whole lot of things with these .NET classes and .NET modules. And of course, I mentioned before, TIFF images are in many, many different formats. And so, on this screen here, you might have one single bit depth, high compressed image. Another one might be low compression, which is 16.7 million colors. So you can do a whole bunch of different things there. The images may be rotated. There may be, as I mentioned, multi-page TIFF images. That's very popular in the insurance industry. And so there's all these different ways. So I'm pretty much, unless you guys have some quick questions here, I'm going to pass it over to Thom. Any questions? Is it making sense? Am I going too fast?
No, I don't know. Do we have any questions from anybody in the chat room at all?
I understand it perfectly. I hope you guys do.
There you go. The main message is there's a big need for this. There's a big need for this, and there's a big desire for this.
So you made a comment that you're redacting portions of the image from the XY coordinates. So I'm assuming that means that the base area of the image is assumed to be in the correct location. So what if the image wasn't scanned incorrectly to begin with?
Right.
And so if you have a large batch of images and you're all expecting them to be like checks, and they're all that the lower left corner is where it's supposed to be, but there's a few that aren't scanned properly, so the area of an address, for example, isn't in the same location for other checks. So how do you take into account something like that?
Yeah, exactly. So there's two ways to redact an image, a TIFF image. One way is through XY coordinates, is what you were talking about, but is what we were talking about earlier on. Another way is through OCR, optical character recognition. So we used a free engine called Tesseract. I don't know if those of you have heard of that. There is a yep, they're good. So there's a quote free OCR engine that you can do a lot of modifications. So in that example, what we've done is we will do an OCR against the TIFF image and determine the text. And we can also, with the optical character recognition engine, and it's free to, you can do a lot of PowerShell examples on Google for this. You can do a whole bunch of things. So it'll scan the TIFF image, get its best, what it thinks is text, whether it's rotated 90 degrees or 180 degrees or not, and then it will automatically return the XY coordinates of each word. So if we're looking for something particular, we can do a regex for that, like a regex for a 9-digit social security number or a regex for a 16-digit MasterCard number or something like that. We can run an OCR against the image, find the location of that 16-digit number, for example, and then use the stuff that Tom's going to show you to redact that, or intelligent redact it, or just put black boxes or white boxes on it.
Okay, so in that case, the XY coordination is coming after recognition of the text itself.
Yes, correct. The Tesseract OCR engine will do that for you.
Okay, all right.
That takes care of rotation, right?
Yeah, it takes care of rotation. It does a lot of things. You can do the way we've modified Tesseract is we've set up where Tesseract, because it's a performance hit when you're scanning an entire image, a single page TIFF. It takes time. There's cost there. And when you talk about millions of TIFF images, you want to process them as fast as possible. So we recommend the XY coordinates if you can. If you can't and you need to use OCR, what we did with one customer is they have sheets. They have insurance claim forms, but on the bottom right-hand side, they have the insurance claim serial number. So instead of scanning the entire, we did a hybrid approach. Instead of scanning the entire document or the entire TIFF image, we scan the bottom right-hand corner, a certain amount of pixels, to detect the form that is there. And what we can do then is apply some sort of policy or rules to mask that image, because now we know that it's a specific type of insurance claim.
Okay, cool.
So it's a much faster, and it's super not super fast, but almost super duper fast. But that's pretty much it. So the cool thing is, like I said, there's a need out there for your company and for you guys, and this is a way to do it without any type of third party. I'm going to pass it over to Thom, and I'm going to be around to just ask any questions, and I'm going to go pour myself another glass of water.
Okay, well, okay, so what I'm going to show you is we're going to get the encoding for TIFF, set the encoding for TIFF, get an image, read the file, create a blank canvas, create a drawing method, load the image into that, draw on the canvas to save the file, and then we can do it over and over and over again. Okay, so if you'll switch to my screen.
All right, I shall switch to your screen.
We'll begin with the last thing first. So I have several different images that are on my desktop here. I just put them on my desktop. You'll notice that each one of them is a bank check.
Are they yours?
Does
it have your
It has Peter Van Costigan, I guess, whoever that person is.
Okay.
And we have the way we've actually written this particular routine that we wrote will do JPEG, lumps, TIFFs, and we have yet to work on. There's a little piece we have to work on with TIFFs with regards to how much compression you use. That we have yet to completely narrow down. So it's still a little bit of work in progress, but you'll get the general idea of the entire script here. So for the very first one, I have this script I called draw rectangle, because that's exactly what it's going to do. So we're going to take one of these images on the desktop, this one being the JPEG image, and then we're going to give it a new path, which is again on the desktop. And then we're going to draw a rectangle height of 40, a width of 550. And then the X and Y coordinates are pretty much all the same, 100 and 350. All these are the same. We can vary them. If you guys want to see it varied, I'll show you that it actually moves as well. So with that in mind, I'll just go ahead and run this very first line here, which now if we look at our desktop, we should have a new bank check image. And you'll notice it redacted the item down here at the bottom of the screen. Okay. And that was, so we took a copy of the JPEG image and created another one called redacted JPEG.
I got a strange question.
Okay.
Well, you're from Australia.
Do JPEG support metadata attachments to them?
Yes, you're talking about meta, like geolocation and stuff like that.
Yes, I do.
Yeah, or is it expandable? Like, is it a fixed size, or you can go as big as you want?
Don't know.
Okay.
Sorry, it was a bit hard to hear. What was the question?
He was asking if there's metadata in the JPEGs, if it's expandable.
Yes, yes, you can pull that data out. Yeah, and we've done that. And you can edit that data as well.
Are you asking, can you get at the metadata that's in a JPEG with the .NET classes? Is that what you're asking?
It's happened before that people have used the metadata attached to images, especially on Twitter, to find out where people live. Because the geo is automatically attached when you use your phone.
Yes.
Yep.
Yes,
So
we're
that
familiar
is-
with some of those examples. Yeah, well, so what we've had a request with that, because a lot of cameras and a lot of cell phones as well, that most people take pictures on the cell phones, record the GPS location and time and other information, and whether you share that or not, it's always embedded inside the JPEG image, so as in the metadata layer. So yes, we've had a request to obfuscate that information.
Have you had any requests to remove the yellow dots from any copyright pictures?
Oh, microphone's breaking up. Problem with the microphone. No, just kidding, guys.
Does this handle dynamic sizes? So say if somebody scanned a check at the wrong size, DPI or something like that.
I'll get to that answer in just a minute.
Thank you.
Sorry, Tom,
so-
go ahead.
I just ran the second version of the script, which is the second line that you see highlighted there. And it happened to be this TIFF2 image, which this is, what's the format of this image, Alan? Because I don't remember all the detail on it.
Oh, it's like 2-bit depth. It's just black or white, and I can't remember the compression module used, but it's the middle. The reason why these checks, so there these type of checks that you're looking at here, you think, why doesn't everybody just do a full color, full depth checks? But there's a format in the banking industry called X937 where banks share check images between each other, and they share in a daytime, they share millions of TIFFs images. So there's an industry standard in the banking system and insurance companies as well, for example, that have a certain type of rule of how the check must be processed. And sometimes these checks are just like you're looking at a black and white 2-bit depth uncompressed type of images, because this size of this would be probably 1K or 2K.
So, John?
Yeah.
So when I see, so on your code there, you know, when it comes time to code your script there, is there any kind of tools that help you figure out the coordinates of what you want to redact?
Well, very good question. Why don't I go ahead and step into the code itself? So you can see that it actually works. I'm not going to go through all the examples. So we'll just step right into the code, which I ended up calling it draw rectangle because that's exactly what it does, is it just draws a rectangle on this check amongst a little bit, as well as a few other things. You notice line 1 is my parameter statement. And we'll get into these functions in just a minute. So the very first thing we need to do is on line 40 is actually set up our compression or encoder that we're going to end up having to use when we save the image. So this is where we're actually pulling in a .NET class, and we're setting it to compression. I don't remember if this is an enumeration. No, it's just a class. We're actually pulling in this class with this method, this static method here.
Factory.
Pardon me?
Looks like a factory.
Yep. Then from here, we're actually gonna, as part of the parameters to set this up, you have to have an encoder parameter to tell the method when it saves, how many, what depth you want it, all that kind of business. So we're set, right here, we set up the encoder, how many encoder parameters we're gonna send. And then this line 43 is we bring in our encoder in the drawing image encoder parameter and set the type to 4. This is for the TIFF images. Then we take the, we put the parameter in the encoder params object. Now, what we're going to do next is we're going to get the image type from the image path that was passed. So I'll go right into this function, get image type. This image type does is that the first thing it does is it opens the file with the system drawing image from file. We do open the file name. Then I actually cast a variable to the system drawing image format. And what this does is it allows us to get at the types of images that there are. So if you look at this particular class, you look at this class, you'll notice that there are, here's all the different types that you have. There's bump, EMF, EXIF, GIF, icon, JPEG, memory bump, PNG, TIFF, etc. Here's all the different image types that you have. So what I found to do, the best way to get this data so that I could compare it against a GUID for the image format.
Is there a similar enumeration for the compression type?
I've been looking for it. That's part of the reason we haven't finished it, is I haven't been able to figure it out just yet. I'm close. I haven't figured it out completely yet. So what I did to be able to get the type that we have for this particular image, if we look at the image raw format from raw format. Oh, wait a minute, I need to break into this. In any case, if I was running this and I had a breakpoint, we'd be able to see the data. I'll do that in a minute. When you look at this object that you've created, because it's from the file that we actually are looking for the file name, there's a raw format property, and then underneath that is a GUID. You have to actually go into the GUID twice. I don't remember exactly why. So then what I do is I compare it to our T type GUID to see if they match. If they match, then I set the value equal to the type that I'm looking for.
You loop through it until you get the right one.
So then after that, then I dispose the image and return value. If I don't find it as an image, then I return that as file name is not an image in the catch.
Can you go down to line 43?
Sure.
We have an encoder. So what is the 4 then?
Sorry?
Where you have my encoder, and then what is, and you have the type is 4?
The 4 has to do with, it's a byte that you tell the encoder parameter what kind of compression to use, and I haven't completely figured it out yet.
Okay.
Yeah. In the TIFF images, there's so many different compression types. There's CCIT4, which is a compression level 4, so that might be that. Go ahead.
Okay, so the 4 is referring to a compression type that's embedded in the image?
Yeah, CCITV, there's different types of TIFF compressions out there, algorithms out there. So number 4 is saying to use that compression, because if you use it as default, it will save the TIFF image instead of a 2-bit or 2-byte, it'll save it as a uncompressed, and instead of getting a 2K TIFF image or whatever it may be, you're getting yourself a 57K TIFF image, and that blows up systems.
Okay.
So at the end of the day, line 45 in the image type variable, we're going to either have JPEG, bump, GIF, whatever the image type is. Okay. Then on line 47, we're going to use that value from what we got for the image type to get the codec info that we need for the image codec. So if you look over here, there's our image type. Okay. This took us a while to figure this all out, by the way. Yeah. Didn't it, Alan?
Oh, took a lot of
All
bottles of
day
wine.
Saturday one day trying to figure this out. Okay.
So those where you're searching for where you're searching for parameter names, they're not actually concrete code objects. They're actually image metadata elements.
Yeah, so if you look at this image encoders, there's actually quite a few encoders in here. And I was trying to draw the corollary between the new encoder parameter and what's in this get encoders, and I haven't figured it out yet. But if you look at this object, you'll notice that there are quite a few. Let's see what the count is. There's 5 of them in here on my machine, 5 image encoders. And I ended up picking the property called format description. And that format description, see, there's the encoder type for PNG, for TIFF, and that gives me this object so that I can use it when we create the file.
Does this sidetrack your talk? I was talking about this sort of thing,
Pardon me?
these little details.
No, it's fine. That's what the intent was. All right, so moving on. I could have actually just gotten the image resolution from $org, which is our actual image, the starting image that we started with. But I decided to create a function that would return exactly what I'm looking for. So this get image dimension and resolution, what that does is it, again, we open the file. We have to tell it, in order to do this file stream, we have to start a new file stream, give it a file name, tell it that we're going to open the file with the system IO file mode, and then set that file access to read. So those are all static methods on those .NET classes. You can see whether we're using the .NET classes pretty extensively in the script. Everybody understands that the square brackets mean we're actually calling a .NET class, right? Paul? Okay. All right, so from there, then we read the image from stream. So now we can look at the information inside of the file itself. So now we can, I just return this PS custom object that gives the physical dimension width, physical dimension height, horizontal resolution, and image vertical resolution, and return it back to the caller. But of course, you need to make sure you dispose your memory by doing the image.dispose and the file stream dispose that you see here. And then we just pass it back to the caller right there.
And that dispose is of the original image memory.
So it actually pulls it in memory so you can read it and do everything you need to do. If you're running in C#, you have to do the same thing. You have to dispose it. You do a file stream and then read from that stream to get what you want, and then you got to close them all.
Okay. So once you get what you want, then you're creating that, putting that into your file directory.
Well, I actually put it in a PS custom object that I returned.
Okay.
So, and just a flat variable that you see here. What that variable will have is, it'll have file name, width, height, horizontal resolution, vertical resolution. What I'll actually do is I'll finish explaining this, and then I'll put a breakpoint and we'll walk through all of it. All right, so this is where this ORG is our original image. We get our original image here, we get the resolution. Now we're going to create our canvas. So this $BM, I know it's not bowel movement, it's actually bitmap, I think is what it meant. I thought I'd add a little bit of humor.
We did just have barbecue.
Yeah, exactly. So again, we're going to create a bitmap image, and we're going to use the original object that you see with the first parameter is org, which is our file. And then we're going to use its size and its height so that we can draw it exactly the same size and height. We're just actually making a new bitmap with the original image. Okay? So we could actually change those parameters to answer your question that you asked earlier. We just got to change the object when we're in here, whatever it is we want to change it to.
You're scraping the, for lack of a better word, metadata,
Yeah.
the width and the height. So that's cool.
Then the next thing that we're going to do is we're going to actually we're going to create a drawing image so we can actually draw on our canvas. And what I do during this draw is I have one check in here, which is to make sure that the X and Y coordinates are beyond the bounds, which is what, there's several other checks we could do. We just didn't have enough time to do the rest of them at this point. But I just wanted to demonstrate that we are actually doing a little bit of error checking in here before we get out of this actual script. So now with the G object, we'll create a rectangle, and we're going to use a white rectangle. Now that system drawing brushes is actually an enumeration, so you could use whatever color you wanted. There's many different colors. I can show you the enumeration. If I can spell. So you can see we could have changed it to antique white, aqua, whatever it is we want. And then what's really cool with PowerShell is we could actually specify that as a parameter. And if you use an enumeration as a parameter, it will only give you those selectable options.
Blanched almond.
Yeah. Is there any chance we could use hex like a real person? Hex, the 6-digit HTML code that
It might
we
be brush or singular to do that.
I don't know.
There was a method before brushes just called brush. It probably is a RGB brush.
Yeah, there you go.
I don't know. Doesn't look like it.
We'd have to look it up. I don't know.
Yeah, I'll do that.
All right, let's see. Where am I at in here? Okay, so again, there's our X and Y width and height that you saw in the original parameters. Now we're going to save it. We have to save it with where we're going to save it to, our new image path, with our codec information and our encoded parameters that we saw from earlier. In order to save the file, we have to have all those to be able to save it. Then the last thing in here is if we have a G object, we're going to dispose it. If we have a BM and an org, we're going to dispose it.
We'll dispose of the boundary.
Yep. Dump it, right? Isn't that what you're thinking? Okay. So let me go ahead and put a breakpoint in here at the first line, and we'll run the next one with the breakpoint in it. I think it's this one. See if I get it done. Third one. Okay, so here we go. We're at line 40 with the encoder being created, so we'll go ahead and step through that. I need to turn on my function keys. Bear with me a minute. So now if we look at the encoder parameter itself, we should see that's what we set up the encoder for, was that GUID. And then if we look at the encoder params, we actually created an encoder parameter with no item in it that you can see in line 42. The enc, what is this, ENK arm. This has the encoder param that we're going to shove inside of the encoder parameters parameter object, which is on the next slide.
As a relatively newbie to PowerShell, I've noticed sometimes when you do output these values, you get a few columns, but sometimes there's actually more.
PowerShell automatically does, for some commandlets and some items, it won't show you everything. It'll only show you enough that fills the screen.
Okay.
If you do encoder, like if for this particular one, you could do select star, and we'll give you if there's more objects, it'll give you the rest of them.
Okay.
I don't remember exactly the full detail of it, but yes, you're right. Get process does that.
Like a default output setting, then you can override.
Yeah, it's a config file XML, right?
It's actually probably in your.
In the built-in modules, yeah.
Okay. Let's see.
Does anybody know whether all of these features are available in .NET Core?
If the last release, they weren't doing anything with Windows Forms, and I don't know if system imaging.encoder and all that stuff is actually in .NET Core or not. You have to look.
Sure.
If it's in .NET Core, then PowerShell can use it. But the short answer, I don't know how much is in there. I'd have to go look. I'd be surprised if they don't have it there by now in the next version.
Was it like May that 7 is supposed to be beta?
How do we make the move to 6?
So you'll notice the function that I wrote that I walked you guys through. The image type is actually a BMP. That's what the return result from that get image type was. And this particular item here, we'll step through this. Here's the codec info that it picked out that we're going to use in the creation of the file. It has all the pertinent detail that it needs to be able to create it.
I guess in the data you're getting is like a big blob, right? It's not no extension, no real name, file name.
Sorry?
So in a system where this is getting submitted to a website or something, data doesn't come as a nicely formatted file with an extension that says BMP. It's normally like a big fat blob,
So-
and then you just gotta go look at the coding. Right?
From my understanding, I helped Alan with this because he had that very scenario where there was a huge file that was in a particular format, and there were TIFF images strewn throughout that file. So you had to look for the TIFF markers for each one of those files.
I think we
So-
have two parameters at the top for mask and something. That is the first byte of the file.
Yeah, the first 2 bytes of a file type, if you drag, say for example, if you drag a TIFF image or a JPEG image or PDF document or a Microsoft Word document, if you drag that into Notepad++ or whatever editor you use and see the binary lookout, the first couple of bytes will give you an indication what it is. So the cool thing is, regardless of what it says, like, you know, I know some people, what they do is they have executables. They can't send it to their work, so they rename the executable to .jpeg, attach it. I've never done that. But I hear that these people do that. So what happens is if you want to test it yourself, just grab a TIFF image or any image, drop it into Notepad++ or Notepad, look at the first 2 bytes, and it'll give you 100% indication, or close to anyway, that what type of file type it really is.
Did we get to your answer?
Yeah. I'll just looking at Azure blobs and stuff like that. Yeah,
I think they were at the top of this. I'm not sure if it's this one, but there were 2 lines, a mask and
Submounts.
In one of my functions that I wrote?
no, one of the objects when you printed it out, it had 2
Okay.
masked. It was looking good.
Yeah, we can go back and look. I think it might have been,
You don't have to, but I was just noticed it when you printed it.
okay. I'll keep going then and we'll come back to it.
Yeah.
Thank you, Hal, for keeping me straight.
Gotta keep you on track.
Thanks, Dave. All right, so
a bump is a run length encoded file. I didn't know that.
So again, here we can see the this org file that you see here. It actually has the physical dimension and size in here, and that's exactly what this get image dimension resolution is doing. actually looking at that value and returning it for us. So now if we look at the org size, our size for that bump file is 980 by 411, and the resolution and the vertical resolution are there. Okay. Now we're going to create our canvas with the next step. So again, there you can see the height, the resolution, the raw format, all that extra detail with this particular object. And then we're going to set the size to the size of our original image. Now if we look at it again, it should have changed. 980, 411, 7209. Okay. Moving on. Now we're going to create our graphics so we can draw on our canvas. And then we created our image. And then here we're going to do the test, which X is 100. And what's our original? So it's less than 411, so we're good. Y is 350, original size. 980, so we're good. So it should go right through. And here's where we're actually going to draw our rectangle on the G object. So again, we can change whatever brush color we want. So we could actually make another parameter for our user if they needed to change the color. And then here we save it. And then we're going to dispose it. So now if we look at our desktop, should have a third check, redacted bump. So you can see with just this small script file, we could actually do as many images as we needed to do. The only thing we have left to figure out is the actual the TIFF compression and getting the parameters for the TIFF and compression correct. Because right now, if we pull in this file the way the compression is set with this bank check TIFF right now, it'll turn it into this monochrome image at the moment with the compression that we have set for it.
Can I show something, Tom, on my screen real quick, just to add to that?
Go ahead, man.
All right.
Flip it.
You guys share your screen?
Share your screen, buddy.
Yep, no worries. It's just... All right, here we go.
Is that one of the Baldwin brothers on your screen?
Yeah, wise guy. That's an old picture. I gotta update it. How do I share my screen here, guys?
Left side, find the green icon with the green T screen with the share icon.
Okay. So
You see it?
Nope.
It's a toolbar that pops out. Are you on Hangouts? Can you see us?
Oh, yeah, the left-hand side where it says screen share. Okay, got it. Okay, sure. Thank you. Okay, so tell me when you can see my screen.
Oh, we can see it now. Go ahead, man.
Okay, yeah. So let me just show you something real quick. Some of the capabilities. I mean, we're just showing you some really basic stuff, but it's very powerful. The knowledge that you have here. We have this Peter von Costigan, Cody Street, Fremont, California. If we run this, let me just double click on this and create a copy. You'll see that we just created a copy here of that. And so now it's down to Thomas Schumacher. And you'll see that. So we can, this is
Nice.
Very, very powerful tool. You know, this technology, I mean, this knowledge here, not technology, just the knowledge that we can do this. All of us guys using PowerShell can do this. It's pretty cool because we can do some pretty cool manipulation. Let me show you one more thing. Tell me when you can see my screen here.
You can see it, dude. Go ahead.
All right. I don't know how clear this is going to be, guys, so let me know. But I just ran this PowerShell script. I just ran the script. This is a TIFF image. Let me ask you guys. One is not only did we use this, what you're seeing here about redacting the information, but we can reduce the footprint of the information with minimal loss. So let me ask you guys. So not only did we redact this scan TIFF image using the technology with the PowerShell, but let me ask you guys, which one of these files is reduced down by over 90%. So one is an 8 megabyte file. I think one is a 700 or 800 kilobyte file. So,
give them a second. They're all walking up to the screen to have a closer look.
All right, let me zoom in for you guys. Hang on a second. So one of these two is an 8 megabyte file. The other one's an 800K file, 800 kilobyte file.
Can't see any
Why you stumped
artifacts.
the chump?
Hang on a second. Let me zoom in a little bit more. Maybe zoom a little bit more here.
So far, the consensus is the one on the left is the compression.
The one on the left is the compressed one? Okay, I don't know. So let's have a look at this. Let's hit File, click on Properties. The one on the left is, say, 300 dp. Oh, hang on a second. Let's see this. No, the one on the left is 8 megabytes. You see that? The one on the left is 8 megabytes. Actually, maybe the right is the same size. I forgot. Hang on a second. Let me check. We'll all be okay. So one on the both eight. No, hang on a second. Let me check.
Wow, that was a great exercise.
Yeah. Any questions? Hang on a
You stumped
second.
the chump for sure.
How
I think
about
you were the chump.
Yeah. How about I open up the correct one? Okay. Let's have a look at this one. All right. Let's do this one more time. Okay, so all right, so now which one is the one with the?
Did you play the shell game with them? Did you move them around, or are they both at the same? Yeah.
I moved them around. So let me zoom in a little bit more. 1, 2, 1, 2. Left or right is the original. One's 8 megabytes, one's 800 kilobytes. I hope.
One on the left is original.
No, the one on the left is the compressed. The one on the right.
Let me zoom in more. Let me zoom in all the way in here. How about that? One is 8 megabytes, one is 800 kilobytes.
Wow, there's no artifact.
Original's on the left, the small one's on the right.
That's what I would say.
Small one's on the right. Okay. So the one on the left is 900K. 900K. The one on the left is 900K. The one on the right. The one on the right is 8 megabytes.
See the artifacts there? see this little section here? You see a difference between?
Yeah, let's keep zooming in. I mean,
Dirt, yeah.
The dirt goes missing.
Yeah.
Yeah, you're right.
so with PowerShell, we can not only redact images, and these two are redacted, which looks the same, right? You don't even know. Not only can we redact the images, but we can manipulate the images to get some really intelligent cleansing of data that is not needed in this. So imagine, so I've seen content management systems are 35 terabytes. There's, so these people are sending documents all day long. So imagine reducing the footprint of this down from 8 megabytes by 90%. So your 35 terabytes gets reduced down to 3.5 terabytes. So your networking moves much faster. Your content management moves in check in and check out. Your Hadoop systems. So there's a lot of power of this knowledge here that Tom's showing you.
Well, we did it together, dude. It was a team effort. You knew all the TIFF image format stuff. I just helped you with the .NET classes and getting them pulled in.
You did boxes. Do you have any code to do the writing to Thom Schumacher style, or is that?
That's something that Allan's done. I haven't seen that yet. Yeah. Did you hear the question, Allan?
No, can you ask the question again?
Do you have, he was asking if we had something to do the writing, right? Like to do, like text instead of a box.
Yeah, I don't have it handy. I don't have the source code handy with me right now, but where it says draw rectangle and things like that, there's an option there for draw text. You specify the font size, and then the actual the text. So you'll say Arial 12. Then you'll specify the Arial 12. You specify the text that you want to put in there, and you draw it at a certain point, like I did with the checks that Thom was that I showed here.
Can you distress the font to make it look more like the photocopied original, or is it nice and clean and?
No. The short answer is you can use any font that's it's on this machine. So let me see if I can find this information up. But yeah, short answer is you find a font that you like. There's a font. I have a font that has over 20,000 fonts, and you just scroll a font browser. You just scroll through the font that likes. That's Papyrus, or that's you've got ones that are like Teletype, that Impact. It's called Impact, I think, that looks like a check image that has been impacted. So there's many different fonts that you can use to make it look as close to real as possible. Also, you can set a transparent mode. So instead of doing you can set it to transparent to 80% or something like that, so it looks kind of faded a little bit. You know what I mean?
Cool.
So how can you use this to be protective of a nefarious intent? Where someone's trying, like they're trying to, make a document look like it was existing when it actually didn't, and then, therefore to advance their cause or to hurt somebody in a way they're not supposed to.
Yeah, exactly. So we've had that request. So we've got a couple of thoughts on that. So, how do we stop a breach from occurring? So in my company, we don't stop breach. We do analysis after a breach occurs. So basically the technology, what we're looking at here is not necessarily to stop a breach from occurring, but to render the data that they access useless. So think of Ed Snowden. Ed Snowden downloaded to a thumb drive or to an IP address all these documents those years ago. With this, depending upon which IP address, which domain, which user, which group, or whoever is accessing, you can write a solution to say, if this person does not have access from this IP address or this user group or role, you can obfuscate at a certain level by masking those critical bits of information. So one note between us guys is that there was a company that asked us, they said, look, we need to know who's reading our documents. So what we did was as the person read the TIFF image, we modified information inside that document so we could trace back when this person's sister opened up a checking account and opened up credit cards. This lady that was working at a call center, and she was taking calls and looking at information. So what this customer did is we embedded signatures, almost like a watermark on the image, but not even inside the metadata. In between the pixels, we created this image that whoever was looking at it, it would log their information in the image, in the white space between the pixels, and that way we could determine the source and the flow of this image. You can do all that with PowerShell right now that you guys just learned today.
Okay, so then what about going further down? So let's say that this image is been in the white space, your watermark has been put in place, or something has been put in place. Can you use this to then look at that image and then say, yes, it's been modified, no, it hasn't, this is the original, this is 3 generations past the original?
Yes, we can do that. You can do that with this technology. Yeah, you can embed every time. You can do an action every time the file is open. But there is technology now in Windows that says that, sometimes you'll get a message, this file has been modified, or this. So what we do is we create a solution. Think of it like as Norton antivirus. Every file you open on your desktop or on your computer is scan through Norton antivirus. We have that sort of technology where we can put that on a file share or on a system and be able to modify who's accessing that.
Are we getting to the answer you're looking for, Remy?
Yes and no. I think my concern is along the lines, you've seen some of the stuff in the news, stuff they're talking about deep fakes in the sense of going with video. And so I'm saying, okay, this is not video, but it's similar. So what I'm saying is that what can this, it's obvious that this could be used to create a fake document or a fake set of documents or a fake set of images.
Right.
That's not there. So my question is, how can you use this to prove this is fake, this is real, or it has at least been modified, and so therefore is not completely.
I think he got to part of the answer by what you could do is if you know that you're editing it is before, like if you're displaying it on a website or you're doing whatever you're going to do with it, whoever looks at it, you could actually embed between the pixels who looked at it.
And I guess
when it was looked at or modified.
Along the same lines, I'm wondering is if there's a way of saying that it's almost like
to prove that you're innocent.
Is it possible like blockchain where you say every time that image is looked at, there's a modification that shows you that it has been looked at, that you can't you cannot go back. So once it's opened, there's like a blockchain. That's the next iteration, so that you can't say that's the original when it's now 25 versions down.
Yeah, okay.
It's a one-time key type thing.
Right. So that's how blockchain works. Is that it's like okay, that's the original. No, it's not. You're at 37. Okay, so
right.
And you can't modify that. And so I'm wondering is if there's something embedded within the PowerShell code or the image piece that's saying that okay, this is an image, it's been modified.
Natively in Windows, no, but you would have to write it.
Okay.
You would have to write it. You could actually write it.
And in short, if you're using the an image editor or browser like for example Photoshop, or that is opening and that's at the operating system, that application starts up to view that, you need to intercept the image before doing so to modify that. So there's some challenges there, but I think Thom is right. The short answer is yes, you could do that.
Almost like from an organizational standpoint, you could say let's say an insurance company, their field people, they have all these images. The images come into the field database, and you can run a PowerShell piece on it that puts that blockchain identifier, for lack of a better term, onto all the images, and saying as the image comes into the data center for the insurance company, here is quote unquote 01. There it is. And then anytime that an image is looked at after that, because as it was first became part of the insurance company's database, it was given that moniker, so that moniker sticks with it and then gets modified from there, but you always have that original moniker.
Yeah, you can do that with this technology.
Just a digital signature would be good enough to say.
Yeah, I was going to say, digital signature on the original should protect it from being changed.
Well, you can tell the original is there, but you want to keep track of, hey, it has been accessed this many times by this many people. This person said they got the claim, this person said they didn't get the claim, this person said you owe us money. So that if there is miscommunication within the company, you see the transition. Oh, this person said this because somebody had modified this one figure over here.
Yeah.
Very interesting.
Well, this is what we had to show this evening. We're almost done for tonight. I think it's almost 7.
Oh, I thought you'd go home at 8.
Did you,
No, 7.
did you cover, my question, maybe I was dozing off, but on how you figured out the coordinates to what you wanted to redact?
Via code, no, I didn't. We didn't do it via code at this point. What I did is I actually picked a set of coordinates to put it on there.
So
as Allan had indicated earlier, what you could do is you could run the OCR program and find where the text is that you want to redact and use that as your starting position. And then so that you don't have to OCR a check or whatever it is you're going to do every time, assuming that you're doing several thousand images of the same type of thing. Then you could OCR it once, find the X and Y coordinates where you want to put the redaction, then redact it, and then go on about your merry way.
And then once you run through a batch,
is there a plan or is there a way to do a spot check, say like quality control, saying, okay, let's check if did it grab it correctly or did it not grab it correctly?
Well,
You mean like a test to see if the image actually
Right.
has that white box in it?
maybe you could
We
do
could you could write a pester test to actually probably test it to make sure that it's there. Do I have one? No.
Okay.
But yes, you could do it.
OCR the same place again. Once you wiped it out, there should be no text.
Yeah, you would have to OCR it. I would think. Well, would you have to OCR it if you draw the box on it? Alan, is that what you would do, or what would you do?
For what's that, Tom? I couldn't hear you. So
Say that you did. Let's say you did 10,000 images, right? And
Right.
you want to verify every 1,000th image to make sure that your process worked like it's supposed to. What would you do to actually check to make sure that it worked? To test
yeah,
it?
so it depends on the resolution and of the TIFF image of the image. But what I do is I take a section. What you could do in PowerShell is you take a section, you count the black pixels versus the white pixels, and it just takes a very brief moment. And then once you do that, and you make the change. You can check and count the pixels of the change that you made, and if there are more black pixels, or depending on if it's a white box that you drew, if there are minimal, a threshold, then you can determine whether that area of that image has changed.
Cool. Can you count exactly to the same bounding blocks as the white box you're going to make?
Yes, yeah. So I mean, a pixel is a pixel, and so if you have an image that's 1,000 pixels wide by 500 pixels in height, you know exactly where and what and the dimensions and the characteristics of each and every pixel when you read those in.
Okay, so it's easy. Cool.
Thanks for the explanation. You did it better than I did. Thanks, Alan.
I've had more wine than you have right now, so
And you've done it a few more times than me.
there you go.
Okay, did we get to your answer? Okay. Anybody else?
Is there like a GUI version of finding the pixels that you
No.
guys?
No, there is. So you can use. I don't know if you. So what I do, I can show you very quickly. I use Windows Paint. If you don't have Photoshop or any type of editor, just use the basic Paint for it.
You just count the pixels that way. Okay.
Well, you could use the other one. You can use is Paint.net. Paint.net has.
Which is free, yeah.
Yeah.
Oh, okay, yeah, that's a PowerShell thing, isn't it? Or
No, it's actually an open source photo editor. It's really
that's
good.
cool. So yeah,
It
use
also
your
works on Linux, doesn't it?
use your favorite photo editor and just draw the box and determine the dimensions. Those for fixed type of TIFF templates, and then you're good to go. And that's what we do a lot. When you're talking about your own personal stuff, you can receive TIFFs in all different shapes and sizes. But when you're talking about big companies and corporations doing millions and millions of TIFF images a minute and things like that, then they're a standardized type of template. So you can kind of definitely leverage the XY coordinates.
Yeah, I forget what the application I was using, many years ago, that it actually showed the coordinates down in the address bar, or not the address bar, but just,
The status bar, yeah.
yeah, the status bar, yeah.
Okay.
Cool. So have you tried Image Magic, or is this you trying to get away from using Image Magic in previous attempts?
Yeah, so exactly. So yes, short answer is yes. Image Magic, GD Picture Shop, Paint. There's a whole bunch of third-party software you can leverage, but you don't need to with this. You don't need to with PowerShell. So
Wasn't the short answer that it was really slow? Wasn't that the other part of it?
there was yes, there was a whole bunch of reasons. There was a performance issue and a bunch of other reasons, but for this one particular customer, this PowerShell script sufficed and helped us out.
And these image libraries, do you know if they're optimized for GPU acceleration?
I don't know. We'd have to look. If they're standard .NET libraries. We'd have to look.
Because they should be exposed to DirectX. Because I know Tesseract you can make like up to 1 million times faster.
Oh, if you use
With the
the,
GPU.
really?
With it, yeah, exactly. Yeah, that's a good point. That's a very good point. So, but maybe next as a follow up, we've done a demo of this for actually body cam using PowerShell, so you can capture these, capture an image. We can analyze the image and determine through facial recognition. We can grab that, put it into an FBI database, and within seconds of somebody knocking on your front door, within seconds of them turning around, you already know if they're a wanted criminal or not. So that's something you can also do if you might be interested in PowerShell as well.
Which markets are you putting this in?
Man, I can tell you're a salesman to some degree, man. Good job.
Yeah. Well, that's it, man. No, I said I can show it to you. I can give you the code. That's what I'm saying. I can give you guys a code we can do as a follow-up.
That'd be
It's
cool,
the
yeah.
same technology.
Follow-up is, how many Amazon drivers did you catch?
Yeah, exactly.
Okay. Well,
Well,
I
I'm
think
going to sign off.
that's all we got. Yeah, thanks a bunch, Alan. Appreciate it a
No
lot.
worries, guys. Take
Thanks,
care.
buddy.
Sorry I wasn't there. See ya. Thanks, guys. Cheers.
All right. See you later, bud.
Thanks.
So you got post information on this on your site?
Yeah, sure.
Yeah,
You
and
guys
this is
want
on
it? I'll
YouTube.
be happy to.
Live stream to YouTube.
So what's the page?
AZPosh.
Okay,
Arizona, yeah,
AZPowerShell.
AZPosh.
WordPress.com.
Yeah, that's the website. So this is the website. AZPowerShell.wordpress.com. And somewhere on here, the YouTube channel is.
If you go to About right there. And scroll down.
That's a giant cactus in my face.
Scroll up.
Ah!
There's a YouTube link in there.
Oh, yeah?
Yeah.
Yeah,
Right
where?
there. To your right.
Channel.
YouTube channel right there. Scroll
Underneath the
down.
arrow.
Yeah, right there.
Right there.
Yeah.
I think it needs to be bolded.
Yeah.
Yeah, it needs to have a
Can
YouTube
you redact
logo.
that? Can you redact that?
Yeah, we
what?
could. Well, I hope you guys found this useful.
Awesome, guys, good job.
Very much so. Pretty good.
Yeah, and that's our Arizona PowerShell. You know it's us because we have a cactus. Nobody else has a cactus in there. So
Where is that photo taken from?
Oh, are you gonna stop the live stream?
Is that the point?
Is that the billboard?
That is a resort my father took me to. It's south, really far south, past Casa Grande. There's a gold mine nearby. I can't remember what it's called, though.
Gold Canyon?
Gold Canyon? Yeah, that's might be it.
Ah, this is Tucson.
That's east.
No, that's north of Tucson. This is, yeah, east. You're right. It's more east. Northeast. Let's go along the 60. You come to this place.
That looks like the superstition, edge of the superstitions.
Yeah.
It does, yeah. Cool picture.
Thanks.
Thanks for that.
Where the hell is this video?
Well, Tom, thanks for having us again and all of it.
No problem. Hey, Tom, what do we have next month?
I think if I can get in touch with Kirk Monroe, it's gonna be Kirk Monroe again. Poshaholic. That's what he goes by on Twitter. Really, really sharp guy that really knows the PowerShell language really well.
Okay.
If anybody's ever heard of, what was it called? There was a editor that a company, Quest came up with a while ago called PowerShell. It had a little train on it. Gosh, what was the name of it? PowerShell.
PowerShell train?
Caboose?
Yeah, you guys are all helping. I appreciate it. Anyway, he was one of the developers for that back in probably 2007, 2008. And he worked for Quest. Do you guys remember Quest software?
Yeah.
They actually produced an editor, like a WYSIWYG editor for PowerShell, sort of, where you could go in and it would help you fill out the commandlets and all that other kind of fun stuff. It was pretty cool.
For people who aren't real programmers.
Yep,
So me.
like me.
I'm me.
Oh, I'm not quite there yet.